Alright, here's a video going over the notes for 6.6. There are two parts. We're going to go over a couple of shapes here, alright? So just jumping right into it, trapezoids, okay? You may have seen a trapezoid before and you know what it looks like, okay? But here are the properties that you need to know, okay? It's a quadrilateral, it's a four-sided figure with exactly one pair of parallel sides. That's what that notation means, parallel sides. And I want to say that many times we see a trapezoid in this orientation, right? But you can make it vertical. It's rare, but just want to point that out. One upper base and one lower base angle are supplementary, okay? Because think about it, those are consecutive angles. Okay, so this angle, hopefully you can see where I'm highlighting. This angle plus this angle are supplementary. It equals 180. Okay. You have a specific type of trapezoid called isosceles, where the legs are congruent, meaning the side legs. Okay, and then you have congruent diagonals, and the upper base angles are congruent, and the lower base angles are congruent. All right, so there could be an isosceles trapezoid. And here are some examples. Using some algebra work, okay, and incorporating the properties of a trapezoid. Right here, in number 1, here's one setup here. You have 6x plus 20 plus this angle here, the 4x, right, equals 180, right? Those are same side interior. Number 2, okay, just again using the angle properties here, all right. Angle 1 is 125 because again they're supplementary, right? This is an isosceles trapezoid because of the tick marks. These legs are congruent, and therefore angle 1 and 2 are congruent, and angle 3 and angle D are congruent. For number 3, this is one of those problems where you can draw in an altitude, right? It's going to be 90 degrees. And so therefore, if you know this is 13, and if this is 11, then you know this is 11, right? That's how we know this is 2, okay? And since it creates a 90-degree angle here, we can use the Pythagorean theorem to solve for RS. All right, that's the hypotenuse here, okay? For number 4, it's an isosceles trapezoid, so the diagonals are congruent and the measures equal each other. That's why you have BD, which is represented by x times x minus 3, equals 40, all right? And so you distribute and you subtract the 40 over, and in this case, the negative 5 actually does work, because if you substitute it in for x, you have negative 5 times, this ends up being a negative 8, and a negative times negative is positive, right? So you always have to, don't automatically assume that it doesn't work when you get a negative. You have to plug it in and see if it works out. Okay, and here we have another example. I believe this is a systems problem. Okay, we have 12x minus 80 plus 3y minus 16 equals 180. That's one setup here. Okay, looks like the negative 80 and the negative 11, we combined like terms and added it to the other side. And then you also have 6x plus 9 plus 4y plus 18 equals 180. Okay, so this is a system of equations problem. It says find the height of the isosceles trapezoid. You can draw in the height or the altitude, and again creating 90 degrees. And we're incorporating trig here, right? Because it creates this right triangle. So from the 38 degrees, x is opposite, and 25 is the hypotenuse. That's why we use sine. And here's the setup. All right. The mid-segment of a trapezoid, okay, is the segment that joins the midpoints of the legs. All right, so on this left side, this left leg, this midpoint, and on the right side, this midpoint, and if you were to connect those, that's called the midsegment. All right, the midsegment is parallel to both the top and the bottom bases, and it has a special relationship in terms of the measurement. The measure of the midsegment is the average of the two bases, right here. And the midsegment is equal to B1 plus B2 divided by 2. Okay, that's going to be important to know. So here, quick example, right? X is the midsegment, 16 plus 30 divided by 2. More complicated problem, right? Same idea. X squared is equal to B1, x plus 4, plus B2 divided by 2. All right, it looks complicated, but if you take it step by step, I think what we did first was we multiplied by 2 to get rid of the fraction. So that's how we got 2x squared. And then 4x plus 6 from combining like terms. All right. And then from, it looks like here, we divided by 2 to get this line. And then we factor. Okay. So again, the midsegment. And then moving on to kites. Okay. There are specific properties here. Okay. Please pause here and take a look at these properties. All right. So notice everything that's marked. Okay. To see what's congruent. Okay. This is also important. The sum of the interior angles of a quadrilateral is 360 degrees, meaning any four-sided figure, no matter what, if you add all the angles, it's 360. Just like when you add the angles of a triangle, it's 180. Okay. And here again, just an example here. Okay. If ABCD is a kite, solve for x and y. Right, we have this set up 3x minus y equals x plus 3 because AD is congruent to AB and CD is congruent to CB. Alrighty. And then perimeter means you add up all the sides around the shape. Another problem here. Okay. We said any quadrilateral adds 360, the angles, and so you add these 4 angles. Set it equal to 360. And here, again, incorporating special right triangles from a couple days ago. Okay, gotta know these, right? And so it looks like, what are we given here? I forgot what we were given. Oh, you're given 12. Okay, in the original problem, I believe. If this is the hypotenuse, and you know this is 30 and 90, then this has got to be 60. And so the shortest side across from the 30 is going to be half the length of the hypotenuse. So that's why this is 6. And if this is 6, and this is a 45, 45, 90 triangle, if this is 6, then the other leg is 6, and x is the hypotenuse, so whatever that leg is, we multiply by root 2. So that's why it's 6 root 2. Alright. And here it looks like we use this triangle that I'm highlighting, this bottom half, okay? That's why we add up all the angle measures and set it equal to 180. Okay, in this problem, a couple things here. We have 4x plus 13 is equal to 5x minus 15 because these opposite angles are congruent in this kite, right? And also, I think what we did was we added the angles in the top triangle to equal 180. Alright, because if you know what x is, then you can substitute it in here. Okay. Here, find the measure of diagonal XC, right here. I think what we did was we used the top triangle right here. We did a trig ratio problem. Sine of 42, we use sine because from 42 x is opposite and this is hypotenuse. Okay, and so when we solve for x, right, remember that's not what it's asking for, it's asking for the diagonal, so you got to multiply that by 2. That's how we got 13.38. Okay, again another factoring problem, right, using properties of the kite. I think this is a Pythagorean theorem because the diagonals are perpendicular. So x squared plus x plus 7 squared is equal to 2x plus 1 squared. Okay, you will have a homework assignment to complete by, I believe, Friday. Okay, but if you have questions, please shoot me an email and let me know.